All right, so in this video, I just want to talk about and focus on capture mode only. Okay, so again, what capture mode is, it does the following. So both CCP modules, they do have configuration registers and they do have some data registers called CCP RX, and X stands for 1 or 2 depending on which one we're using. We're going to be using 2 for now. So CCP R2H, CCP 2RL, okay, these two, if you combine them, they become a 16-bit register. Okay, that captures the 16-bit value of timer 1 or timer 3, depending on which one you're using, when one of the following occurs on the CCP 1 or 2 pins. So we're going to go back to this pin, for example. If something happened on this pin, whether it's CCP 2 or 1, let's focus on 2 for today. So you're going to see me now. I'm going to show you that I will be connecting, for example, a switch here, and we're gonna see what would happen when I connect the switch. So usually this is a capture input, okay? So if something happened on that pin, and which is basically every falling edge that happens, what you do is you go to the value of timer 1 or timer 3 and you capture it. It's as if you're taking a snapshot of it and you're storing it for some reason or another. Okay, you can do it on an every falling edge on that pin, or a rising edge, or 4th rising edge, or 16 rising edge. You can actually set it up the way you want to, okay? And then the way you set it up by setting up the configuration bits. So let me show you. So there's a configuration bit here, and you can see that we have capture mode every falling edge, every rising edge, every 4th rising edge, or every 16th rising edge. I will just show you one maybe with every, let's say every rising edge. So if I press a switch and then I remove my finger, if that switch is basically connected to a pull-up resistor, that would be the mode that we're going to operate on. So just to show you what's actually happening, it's a simplified block diagram of what's here. So this graph might look a little bit on the complicated side, but what I want you to know is the following. All these T33, CCP or something, they're pretty boring to explain, but they're showing me which timer is the one that is triggering. So whether I'm using timer 3 or timer 1, whether I'm using timer 3 or timer 1. And remember, I have a CCP 1 and I have CCP 2 in here, okay? So all of these AND and OR gates and NOR in here, they basically tells me, it's just explaining all the details of whether I'm using T3 in both cases, or I'm using T1 in here, or T3 in here, and so on and so forth, okay? So this one here is you are using timer 3, this one here is you're not using timer 3, you're using timer 1. In any case, what I want you to know is if something happened, okay, and you detect on the pin, so this is the external pin, and it has a prescaler, which is interesting, okay, this is the first rising edge, or the first falling edge, 4th or 16. These are coming from here, okay. Anyway, you don't set up the prescaler specifically. What you do is you just set it up with the configuration bit, and that will be taking its correct value. So if something happened on that pin, whether you're doing the positive edge, the rising edge, or the falling edge, actually, okay. So all of this is, so both of these cases are automatically set up when you choose that mode, the correct mode in the CCP configuration bit. So you do this, 2 things happen. The first thing is actually, because it's a peripheral and it did actually accept something, so it will trigger an interrupt flag. So if you have an interrupt enable, you're stopping your program and you're doing interrupt as usual. And depending on which timer you have, whether it's timer 3 or timer 1, this is the one up is for CCP 1, the one down is for CCP 2. Depending on whether you are, I don't care how the timers are set up and how they interact between the 2 modules, but what I want you to know is in any case, let's assume you're using timer 3, you're gonna go to the timer 3 value, which is 16-bit, and that will trigger a capture mode. Okay, so what I'm doing is I'm capturing the internal value of that and I'm storing it in here. If I'm using timer 1, similarly, basically I'll effectively activate this buffer and I'll be basically capturing timer 1 because I'm using timer 1 as my timer. Remember, in all of the CCP modes, you're gonna have to specify which timer you're using. For capture or compare modes, you can only use timer 1 or 3. The same goes in here, and depending on whether both of them are operational in capture mode and both of them are using timer 3, you'll be issuing like basically the enable in both cases at the same time and whatnot, depending on which CCP happened. Okay, so go through it. It's slowly. It's pretty boring to explain what's happening here, but what I'm going to do is I'm going to show you an example of how we do it. So I have pasted here. I just emphasized this slide. We've seen it before. It just to show you that because we are in the capture mode, so we can only set up that particular module to one of these modes. If you want to turn it off, you put it at 0, 0, and that will disable all modes: the capture, compare, and the pulse width modulation. All right, so let's go through with it. So what you're gonna see me doing is I will just set it up, and here is all the registers that deal with the capture compare and timer 1 and timer 3, because I need to set them up. So this just give me a good overview of all the peripherals that I need to interact with. For example, if I want to set up the CCP1 interrupts, this is the flag, the enable, and the priority and whatnot. Okay, so let me go to MPLAB X, and I'll be back. All right, so what I'm doing right here is I will be, as you can see, I will be using this is not in the compare mode. Let me just remove this here. Okay, this node doesn't make sense. Okay, all right. So what I've done is I set up the LCD in here so that we get to see numbers. I think it's easier to explain this way. And what I have is I have a button here, or a push button. Okay, so whenever I push it, okay, I'll be triggering a capture mode, and you can see that I'll be capturing the timer. So I'm gonna walk you through this example in here, or these codes. So what I have done here is I just went ahead and I just set up my LCD like normal. Okay, I connected my data bits to port B. I connected my data, or the three, the RS, the RW, I forgot which one. Well, RS, RW, and E, I can read them from here. I connected them to the lower significant bits of D, and it's their outputs. Everything is output, and I basically use I'm including the liquid crystal so I can use them. Okay, so what I want to do now is I want to use the CCP2 in capture mode. So I want basically to turn on the timer, and basically every single time I press the button or I release my finger from the button, if it's on the rising edge or falling edge, depending on how I set it up, I'm going to capture or store that particular value. Okay, so let's get started. So the first thing you need to do is we need to set up basically the timer 1. And the way we set up timer 1 is I'm looking here at all the registers that are available to me, and you can follow along whatever I did in the timer. It's basically I'm gonna go to timer configuration 1. I mean, I'm gonna use timer 1. Okay, so I can use timer 3, but I'll just chose to use timer 1. So I'm gonna say okay, timer 1 configuration bits, and I will say basically RD16, whether you want it to read in 16 or 8 bits. I'm gonna choose it. It is 16. It's just if you go to the T1 configuration, let me see if I have it somewhere here. Did I place it? I thought I did. Okay, no worries. I did not place the timer 1 explicitly, but this timer 1 is 16-bit, but you can read it in a couple of cycles, 8 bits at a time, or you can read it together. This one is telling it read it over 2 cycles. This particular bit doesn't affect our code for today, but it's an option that you can set up if you want to. And then the next one, what I'm going to do is I'm going to say, well, T1 run equals 0. I am basically telling it do not turn on the internal oscillator. Remember, T1 can actually have its own oscillator separate from the system one. We're not going to be doing that. We're just going to be using the 1 megahertz. And just so that we can slow that 1 megahertz as much as we can, what I'm going to do is I'm going to set up my prescaler to be 1 to 8. Basically, that's the maximum prescaler that you can have for that particular timer. Okay, and I set it up to 3. That means it's the slowest we can have it. Okay, and then one of the other configuration that I want to do is basically 1 OSCEN equals 0. I'm turning off the oscillator 0. Okay, now here I'm telling it do not use it. Here I'm actually turning it off, so it doesn't work at all actually. All right, so that turns off that particular one. T1 con bits dot TMR1CS. I'm telling it, hey, go use the internal oscillator, basically internal instruction clock. Okay, remember the FOC, like F oscillator divided by 4, that would be it. So if I'm operating at 1 megahertz divided by 4, that's 250 kilohertz, and that's basically the frequency that that timer is operating on. I multiply by 8 because of the prescaler, or I divide it basically, yeah, I multiply by 8, and you divide it by 8 because you're slowing it down. I'm talking frequency, okay? So 250 kilohertz divided by 8, you get that particular frequency. You take its reciprocal, you get the period. All right, next what I will be doing is I'll say, okay, let us turn on that timer. Okay, turn on that timer, and the way I'm going to do it, TMR1, and let's set it to on. Okay, and you can do this whenever you want. I'm just going to basically reset the timer to 0, whatever value it is. Even though I turned it on and it might be like past the 0, I'm just going to say this is my initial value and I want it to start at 0. All right, so now all is fine. What I can do basically is I can just go in and display that value for the timer. Yeah, so let's go do that. Okay, so we're gonna do this here just so that I can show you what's happening. So I'm gonna go home for that, and I'm gonna do to print, and it's tmr1. Okay, and then print integer. This is the one that you should have done for the homework or for the lab. Okay, and then we're gonna do print. I'm gonna a bunch of white spaces just so that it overwrites if it's like a different size or whatnot. Okay, and this is a little bit faster than clear, as you probably remember. Okay, and I don't need a J print, I just need a print. Okay, all right, so let's try to see what happens here. Is it returning 0? Yes, it is. Okay, let's try to do this. It's actually programming it. As you probably can see, you do see the timer 1, and of course it's super fast, so it's actually faster than the update rate of the LCD, so this is why it's jumping super fast. Now, some of you might be wondering, well, I do see like negative numbers. How can a timer have a negative numbers? And the answer is the following. So what we're doing is timer 1 is 16 bits, okay, but whenever I wrote the print integer, it's actually expecting an integer number. So I'm sending it a 16-bit, it's just interpreting it as an integer, and an integer usually is signed. So whatever number, the timer 1 might go from 0 all the way to 65,000 if I'm dealing with unsigned, I'm interpreting it as a signed. Remember, in C programming, the bits are dealt with as much as you want it to be dealt with. Basically, if you have a bunch of ones and zeros and you want to consider them as a signed integer, you will have a signed integer. If you want to not consider them as a signed integer, you want to read them as an unsigned integer, that will be 2. So my program or my function is written in such a way that if I provide a 16-bit here, it will treat it as a signed integer, and that's exactly what's happening. So it's going actually from negative 35,000 all the way to, well, negative 30,000, 32,000, something like that, all the way to 32,000, okay? So I need to fix this a little bit. So what I'm going to do is I'm going to be using the function that I expected you to use in the lab, which is instead of just printing the integer, I will do the following. So I will actually say, all right, let's define some sort of a string, okay? And in C, the string is usually specified as, let's say tmr1. It's basically an array of chars, okay? This is how we do it, or you can do it with a pointer, but this is just simpler. Okay, and now what I'm going to do, this is the function that I expected you to use, okay, sprintf. It's basically kind of like a print, but instead of writing to the standard output, it's writing to a specific string, okay? And now what I'm going to do is I'm going to tell it, okay, I just want you to write to that string. Usually you put a D here and you tell it what that number is, which is timer 1. It's the same as fprint or printf, like if you've dealt with it in C. But D, again, it takes this number and represents it as a signed digit or a signed integer. What I want is I want something that is unsigned. So dealing with this as an unsigned, that should actually take care of that. So I'm going to do now, I have a print, and this stimer is actually a string. So I can pass it normally to my print, and I'm not using printint anymore. So if I actually download this code now, you can see, okay, pause a little bit. You can see that I basically don't have any negative numbers anymore. Okay. All right, so I fixed this, but so far I haven't used the CCP. All I did is I basically took the timer and I just basically displayed it on the LCD. Now what I want to do is I want to take that particular switch in here, and every time I switch it or I remove my finger, basically every time it gets triggered, like first rising edge or falling edge, or every 4, every 16, let's deal with it as 1. I want basically to get that particular value of the timer and just capture it and just store it, okay? And that's the purpose of the CCP. So the way we're going to be doing it is, first we need to tell the CCP I am using timer 1 to actually operate. So what we need to do is we need to go to the configuration of timer 3. This is the weirdest thing, but we're going to have to go to the configuration of timer 3. Where is it? Timer 3 here, and remember I'm using CCP2, so I'm not using it yet, I will be using it, so I'll be basically setting the T3 CCP2 as a 0, and that basically capture, whether it's capture or compare, it will basically do that. All right, so here I'm gonna basically say use timer 1 as my timer, okay, and that basically is done by T3 configuration bits dot T3 CCP2 equals, this tells me put it to 0B00, okay, binary 00, and that tells it use timer 1 for CCP2. That's what's doing it. If I was about to use CCP1, I would have just switched that to 2, okay? Now, what I have in here is I have my switch already connected to that pin that I'm interested in. Let me just scroll up. Remember, we have a bunch of pins in here. There you go. I'm connected it here, but if I wanted to, because I'm using CCP2, I could have just went to the 36, pin 36, which is part of port B. However, now I'm using it for the LCD, so I'm not going to be using it over there, but I'm just going to show you where you would have needed to change, or what you needed to change in order for you to use that particular pin. So you can, for example, go to the configuration bit, and if you go down, you're going to see that something called CCP2, okay, CCP2MX, and this tells it, hey, I'll put it on RC1. Just change it to basically RB3, and you basically will be moving it. It's one of the configuration bits. We're just going to keep it, by default, it's RC1. Okay, and I think older it used to be 0 and 1. Now it's a lot more clearer. Okay, all right, so now we have it. Now we set up the timer. We told the CCP we're going to be using that timer to actually use it. What I need to go through now, and I need to let's see it. So what I need to do is I need to set up that CCP. So let's get started. So I'm going to scroll down to the CCP configuration bit here. Okay, and we need to set it up. Okay, so let's do that. Okay, so we're gonna set up, now we're gonna be setting up CCP2 in capture mode, okay? And the way we're gonna be using it is, okay, try state C bits.rc1. I'm gonna make it as an input, because remember, I'm dealing with a switch. So the first thing, usually I always forget to do this. So whether you're using CCP for capture or compare, you need to specify, even though you're specifying that you're using it as a capture mode or something, you still have to tell it that it's an input or an output. If you don't, which I usually don't, and I forget, it's not going to work. So I'm going to tell it I am connected to an input because the switch is an input. Okay, this is what the purpose of this line in here. Now I can basically tell it, okay, I'll be using CCP2 configuration, okay, and then I'm going to say bits, and specifically I'll be using that CCP2M. So I'm going to do CCP2M, okay, and the value I'm going to use it, basically I have to specify one of these values, whether I want it basically every falling edge or every rising edge or every 4th rising edge or every 16th rising edge. I can specify. Basically, do I want to press that switch 4 times, 16 times, or just 1 time? We're just going to test it with 1 time. And let's say we're going to do it with the rising edge. Basically, remember, this is actually at a pull-up resistor. So when I press it, it becomes a 0. So when I remove my fingers, it becomes a 1. That basically is a rising edge. Okay. So I'll be basically setting up to be at 0, B, 0, and 0, 1. Okay. All right, so this is every falling or every rising edge. That's how I set it up to be. And that's basically how we set up the CCP2. That's pretty much it. So now I need to use it. And the way we can use it is, again, if we go in here, you're going to see, this is the block diagram. You're going to see that whenever something happens and you capture the event of interest, which is basically a rising edge, the flag is going to be raised, and at the same time you will be capturing the value. I'm using timer 1. You'll be capturing the value of timer, well, this is CCP1, we're using CCP2. Okay, so the value of the timer timer 1, okay, L and H will be stored in the data here. Okay, so I can either pull that interrupt flag, or I can just basically use interrupt. I'm not going to waste time using polling the interrupt flag. I'm just going to keep my program just for the LCD display. Okay, so I'm going to raise an interrupt, and I'm going to just have to set up the interrupt. So now what I need to do is I need to do setup CCP2 interrupt. Okay, and the way we do it is, let me scroll down to all these registers that we have. These registers help me. So I need to set up CCP2. So I need to figure out the flag, the interrupt enable, and the priority, and so forth, like what we did before. So I'm going to do PIR2 bits.ccp2 interrupt flag equals 0. I'm zeroing out the flag. IPR2 bits.ccp2 interrupt priority is 1. I'm just setting it up as a high priority, even though I am not using I will not be using priority. I think I have a typo in here. I don't need a T here. Okay, and then I have PIE2 bits.ccp2 IE interrupt enable. I'm just enabling interrupt so everything would work. Now what I'm going to do is I'm going to say, hey, I don't want any interrupt priorities. Just deal with it as a high priority, and that's it. Then here I'm going to basically say peripheral interrupt enable all peripheral interrupts. And now here I'm going to basically enable all interrupt, the global basically enable. Okay. And that's basically sets up what I'm interested in. Okay. And of course, now I know that it will raise an interrupt, and I need to do something with this interrupt. And it's as simple as saying, okay, let's create an interrupt function or an interrupt service routine. So what we do it is void, we say interrupt Okay, CCP underscore interrupt. You can basically call that function whatever you want, and usually it's the same as any other interrupt. We're gonna say PIE 2 bits dot CCP2 interrupt enable. Is it enabled? Has the flag been raised? Okay, CCP2 interrupt flag. That's basically what we do. If that's the case, I know I'm exactly where I'm supposed to be. Okay, and probably I have something's not right here. Okay, so it doesn't like something. Let's see what the message is. Okay, so I'll pause and I'll figure out where the problem is. I probably forgot some squiggly line somewhere. All right. All right, so the error was I forgot to put an R in here, and now everything would be fine. Okay. All right, so now we figured out everything is correct in here, and then of course, because basically now the flag has been raised, the first thing we usually do is we lower that flag, so I don't invoke like recursive interrupts. Okay, so we lowered that flag, and let's, for now, what I want to do is, okay, I want to do the following. So whenever I press that button, I'm going to capture the value of the timer, and I'm going to stop the timer and stop everything so I can actually see it. So what I'm going to do is I'm going to go to T1 configuration bit, okay, and I'm going to say TMR1 on. I'm going to basically set it up to 0. I'll be basically, whenever I interrupt, I'll be basically capturing the value. Let me just show you here. So what's going to happen right now is I'll be doing the following. Something happened on the CCP which basically is pressing the switch. The switch will basically trigger the interrupt, and the interrupt will do a couple of things. It will reset the flag, and it will stop the timer. Okay, but at the same time, while this flag is on, you're going to see that actually the CCP_R2, which are the data register for my CCP module, is capturing the value that is stored in the timer. So I'll be doing two things. I'll be stopping the timer, and I'll be capturing that. So let's see it. So of course, before I see it, I need to actually display it on the LCD so that we get to see it. Okay, so I'm gonna add a few lines here just so that we can see the value stored in the timer and the value stored in the CCP_R2, which is the data register here. Okay, so we're going to do set cursor. Okay, and let's basically move to the new line. And then I'm going to say, hey, this is the CCP2 data register. And I'm going to do something like what we did up here. Let me just copy and paste it. I think it's just easier. Okay. All right. Here, and of course you probably would want to create a function here, but anyway, it defeats the purpose. Okay, char, and then we do s underscore, and let's call it CCP_R2, and then we'll give it an 80 character, even though it's too big, but it's fine. And then I'm gonna take this here, and instead of the timer, I'll do that here, and I'll do that here, and this one here is what I'm gonna do is I'm gonna say CCP_R2. And as it turns out, for this particular compiler, it will know the high and low, and it will just concatenate it. And this is basically a 16-bit value. I don't need to concatenate it like 8-bit and low byte. It's basically the same. All right. So again, what's going to happen right now is you're going to see it shortly. Let me just see that. You're going to see basically my timer is running. Well, CCP has an initial value. Probably I should initialize it to something like maybe 0 or something. Let me just see. Well, I could initialize it to whatever value. Let's initialize it to 0 in here. Where did we set up the CCP2? We set up CCP2 here. So let's do this CCP_R2, and I'm just going to basically put a 0 into it so that initially it has that value. So this is just a random variable or random value that it has. Okay. So now initially it has 0. It has nothing in it. So what's going to happen is I'm going to press that button, but that pressing is actually a falling edge. This isn't what I'm doing. So when I remove my finger, it's a rising edge. And you can see what I did is I captured the value stored in timer 1, and now it is stored in the CCP2 data register. And I have it. And of course, because in the interrupt, I basically, within the interrupt, what I did is I basically stopped the timer. So the timer 1, you can see it as it stopped. Okay, so I'm going to reset again. And with the reset, you can see it's the timer is running, and now I'm going to press it right now. Okay, and it basically captured it. Sometimes you're going to see a couple of discrepancies here with about 2. As it turns out, it's a lot faster to capture the value than actually to stop the timer. And if you take a look at the code, the reason why there's discrepancies happening is because I have an if statement here. And when I tested my code without that if statement, that delay happened to be 1 instead of like 12. It became 13. And the other thing that I think is because we're calling the interrupt service routine, so there's a few cycles that are wasted there. But anyway, so what I'm telling you is basically it's a timer. It takes some time to turn off the timer, but I capture the value of the CCP much faster. Okay, and that's what it is. All right, so these are the two, or this is basically the purpose of that CCP, okay? And of course, what I'm going to do now is I'm not going to turn off the timer. So what I'm going to do is I'm going to keep it running, and I'm going to just show you what happened. So the timer will keep running even though the interrupt. So the interrupt, its purpose is just, actually I can remove the interrupt altogether. I don't need it. It's just basically interrupting, coming, lowering the flag and coming back. But what I want to show you is, okay, I captured some sort of an event now. It captured the value of the timer when I press that switch. If I do it one more time, it will overwrite that previous value and actually capture the new value and so forth. So I can actually use it basically I can keep using it, I can keep using it, I can keep using it as much as I want. So you might be asking yourself, or at least I ask myself, so what's the point of having this module and all this like complication? Why do we need it? And the answer is the following. So now I'm pressing a button, but what if I actually told you, okay, I'm going to press right now and then I'm going to press again, and I took the difference between them. So if I do take the difference between them, I kind of calculated how many clock cycles or how many timer clock cycles it's actually took to do the two presses, and I can actually figure out some sort of a delay. So frankly speaking, we can use it to compute the period or the frequency of a square wave, okay, a signal. And this is what I'm about to do right now. So what we're going to be doing is I'm going to show you how we can use this particular mode. So instead of connecting it to a switch, I'm just going to connect it to a function generator that generates a square wave with a certain frequency or a certain period. And then we're going to program that CCP mode to actually keep capturing the rising edge or the falling edge and just computing the differences between how long it took between these two events, and we'll basically just set it up that way and we'll figure out what the period is. So let's do that. So I'll pause a little bit, do a few connections in here. I'm just going to disconnect the switch and connect my function generator instead and so forth. Okay. Okay, so we continue. So what you do see in here is the following. I just disconnected that switch and I brought a function generator in here. I hope I connected the right thing. Okay, and I connected it instead of the switch. So my input is going to come from this particular function generator or wave generator. So I set it up to be in a square, and the amplitude is going to be, as you can see here, from 0 all the way to 5 volts. And we can set it up like with a 1 kilohertz frequency, or let's deal with the period. That's what we're going to be dealing with. Actually, it's a period, okay? And the period is going to be basically 1 millisecond. So what I want to do is I want to see that particular period in here. So let's do that in here. So I don't need the value of the timer anymore. Okay, so I will be doing this here, and I will remove that guy here. Okay, so that's basically what I will be doing. Okay, so we do remove this here. Okay, so what I'm doing right here is I'll be just basically displaying whatever the CCP is doing. Okay, so as it turns out, like every setup is exactly the same as we did before. I set up the timer 1, okay, to operate at a certain frequency, and I know its frequency because I know that prescaler and everything. Okay, and here what I did is I set up that timer 1 is my CCP timer. Okay, and here I set up that this basically RC1 is an input, which is coming from the function generator, and I'm just going to operate in this particular mode. Let's remember what this particular mode is, which is every rising edge. So, okay, and I'm going to give it initially this particular value. It doesn't matter what value you give it initially, but I'll just basically do that. And I set up the interrupt. So every single time a rising edge happened, every single time coming from that particular function generator, a rising edge happens, an interrupt will be triggered. So within this interrupt, currently we're not doing anything, but what I'm going to do is I'm going to show you what we will be doing. So imagine that every single interrupt we do we do the following. I will basically go and say, hey, timer 1, go back to 0. So what's going to happen is, let me show you on the graph here. What's going to happen is every single time I do get a rising edge, okay, so the edge at the very here, okay, I'm gonna get a rising edge here or here. Actually, in both sides, it's the same. So whenever it happens in here, let's say it at the beginning, whenever this happens, a rising edge happens, timer 0 is set to 0. And then I'm going to go all the way through, all the way through, all the way through, all the way through, and another edge happens. So I'm going to trigger. So what this trigger is going to do at this particular moment, it will capture the value of the timer. But the value of the timer started from 0 all the way to here. Okay, so that value will tell me how many clock cycles of timer 1 has occurred between the two rising edges. And that's basically the period of my signal, which is very interesting. So if I do a 0 in here and I keep doing this, every single time I 0 it, it's as if I actually have a timer. I'll 0 it at every rising edge, and I'm reading its value at the very end. And that basically gives me how many clock cycles I have in total. Okay, so if I'm actually to do this, let's see what would happen in here. And instead of doing that, I'm just gonna basically call it, this is basically just cycles. That's what I am seeing right now. So let me show you. Okay, so instead of showing you the timer in here, what you're gonna see is now I do have like how many cycles. I'm getting 0 cycles. Okay, something is off. Let me just see. Something is off. It's not. Oh, something is off because I don't have any input. Okay, I forgot to turn on the function generator. So we need to turn it on. And basically when I turn it on, it's telling me you have about 28, 29, it depends, okay, about 29 cycles, okay? But that's of timer 1 cycle, okay? That's not very useful. So what we need to do is we need to take that particular number and convert it to milliseconds or microseconds. So this is 28 to 29 cycles of timer 1. But now we go back to timer 1 and see, okay, here's timer 1. And timer 1 is set in such a way that it operates at the internal oscillator, which is 1 megahertz, but because we're dealing with instructions, so we divide it by 4, so that's 250 kilohertz. And because we're slowing it down with a prescaler of 1 to 8, basically I have to divide it by 8. So let's do that with a calculator. Okay, so what I have is, and let's do it that way. It's actually the same way we computed like how timer 1 is actually operating. But anyway, so what I have is I have 1 divided by 4, and that's basically how many megahertz I have. And of course, because I'm having them in megahertz, I need to actually multiply by 1, 2, 3, 1, 2, 3, and that's basically the frequency I'm operating at. Okay, so we divided by 8 because of the prescaler, okay, and that's basically the frequency I'm operating in terms of hertz. Okay, it's about 31 kilohertz or so. All right, so what I need to do is I need to divide 1 divided by 31250, 1 divided by 31250, and that's basically how many seconds I'm spending in 1 clock cycle of my timer. So every one of these 29 cycles, it takes that many seconds to do. Okay, if I'm converting it to microsecond or millisecond, I think I can convert it, for example, in millisecond, I multiply by 1,000, it's 0.032 millisecond. Okay, if I multiply by another 1,000 in here, okay, that basically 32 milliseconds. So each one of these 29 cycles, it takes about 32 microseconds. Okay, so 29 times 32, let's do that, times 29, I do get about 1,000 milliseconds, and that's basically, let's take a look here. Where is it? Okay, here. So if you take a look at that, you can see that it's about 1 millisecond. Remember, this is in microseconds. It's about 1,000. Okay, well, it's about 1 millisecond is about 1,000 microseconds. So that's fine. So what we need to do is I'm gonna just modify it a little bit so that I don't have to do this calculation by a calculator every time. I'm just gonna display it on here. So the way I'm going to do it is by writing it in a separate, on a separate line. And the way I'm going to do it is I'm going to say, okay, this time I'm not displaying the value, the pure value inside that data register. What I'm going to do is I'm actually the period of my signal. Okay, and then I'm going to do sprint f. Actually, it's the same as here, whatever I have in here. Let's show you. Let me show you what's happening here. Okay. We're going to do that, but instead of cycles, I'm going to say basically this is microseconds, okay? And instead of just using the pure CCP R2, what I'm going to do is I'm going to tell you, okay, you need to basically multiply by 4 because this is 4 microseconds. Let me show you where the 4 came from. So the 4 comes from the fact that, here's how I'm going to clear it. It's basically 1 megahertz divided by 4, okay, and then we divide it by 8, okay, and that becomes that, and then 1 divided by 0.03125, hopefully I got it right, and that's basically 32, okay, yeah, because I multiplied by, well, I forgot the 4, okay, so let's divide that by 4. Okay, so all right, so let me repeat one more time. So what I'm doing here is I will multiply by 4, and this is basically the division by 4. Remember, what I'm going to do is here I'm computing in the cycle. The times 4 is because I'm actually dividing every 1 megahertz by 4, and I'm going to multiply by 8, and this 8 comes from the prescaler. Okay, if you don't get this idea of what I did, please ask me on Piazza. I'll be more than happy to help, okay? But what I want you to get is the following. I'm leaving them as 4 and 8, even though we knew it was 32 at some point a year. Okay, all I have to do is multiply by 32, just so that in case you change the prescaler, you change that 8 to something else. Remember that prescaler in here? You can change it if you choose to, and you basically set it up here. All right, the 4 is because I'm dividing 1 megahertz by 4, okay? And now if I actually compile that, you're gonna see, I'm gonna download it. I'm going to download it, and that tells me you do have about this is about 1,000. Okay, so it's not exactly 1,000, it's about 1,000, but you get the idea. So as it turns out, that you need to modify that timer a little bit slightly. Okay, so what I'm going to do is I'm going to add a couple. Remember, there's a little bit of a discrepancy when we do the timer, because by the time you reset the timer or put it to 0, a couple of cycles already happened because of the if statement and the calling in here. So what I did is I'm going to just shift it as a hack. Let's say it's a hack. Okay. All right, so that should get me a little bit closer, and I did get closer now. It's about 1,000. So you might ask, well, okay, what if I put a 3, and as it turns out, it's going to be a little bit over 1,000, I believe. So you're not going to get it exact because maybe because my clock is too slow, so you get 1,024, which isn't the case. So I'm just going to keep it at 2. All right, it's close enough in my opinion. If you do need to operate it as a really accurate frequency counter or a period counter, or a period measurement, basically for that, it's like you can actually go in and do a little bit more calculation and play around with the numbers. So let's test it with a few different frequencies, or I can set it up with a frequency, but I figured out I can also set it up with a period. So if I do 2 period, I should get to 1,000 because this is a microsecond, and I do. Do you see how fast it is? Like all I did is I just changed it and it changed instantaneously. Let's do 5,000, and here I'm still getting 5 microsecond, or that's basically what it is. If I do 10, and this is where basically, oh well, it still worked. Okay, what I'm aiming at is you're gonna get a limit that you're gonna basically reach, and it will start to become problematic. So this is 20,000, for example. If you go all the way to 500 millisecond, and that basically started to become problematic. And the reason why, there's a minimum and the maximum. For example, maybe your timer is actually going all the way and actually going back, and all the way and it's going back, so you're going to get a number. So what I'm saying is maybe the difference between the beginning of the signal and the end of the signal, it's actually longer than the timer can handle. So maybe the timer goes all the way here and then it resets to 0 and then goes in here, so you're going to get a wrong number because your signal has a let's say a very slow period compared to the timer, so it's actually much slower than the timer. Okay, so the timer can't handle it. So the timer goes from 0 all the way to 65,000, and you didn't reach the end of it. So it resets itself and comes back. So you're reading a wrong value, and I think this is a wrong value in here. Okay, so the same goes with if it's actually super fast. If you go to the opposite direction, for example, I want it to be 5 microsecond. For some reason, I think it's. Let me just do that in 20. Okay, let's do that one more time. Something happened here. There's basically an upper limit and a lower limit. So here's the 2,000, and I believe I put it at some point. I put it at. It was too fast. It will actually stuck at 2. Yes, this is it. So it got stuck at 2 or 4 basically. Let me just go one more time. And the reason why is because what's happening is my signal is super fast. It's triggering the interrupt all the time, and basically you're in the interrupt. It's much faster. You get the idea though. Okay, so there's a limit, there's an upper limit and a lower limit. You can change it by changing the timer configuration in here. Maybe, well, timer 1 and timer 3 are pretty much identical. So you can change it by changing this particular prescaler to something. But if you do change the prescaler, you're gonna have to change your calculation in here. Okay, so that's about it. Basically, I just showed you how to use the capture mode in a very practical manner to compute the period of a square wave. So. And this is actually continuous measurement. So if you do, this is it. If I basically try to turn it off, so here's the signal, it's off. I think, yeah, it didn't turn it off, I guess. I guess I'm not reset. Yes, because what's happening in here, I never actually reset the value of the CCP-R2. Okay, so if I wanted basically when I turn it off to be off, I probably should do CCP-R. Well, if I do that, that will be a problem. Anyway, you get the idea. I probably can fix it, but it's one of the corner cases. I'm just going to leave it at this now. All right.